వెల్కమ్ బ్యాక్. ఇప్పుడు మనం ఉన్నాం నానో టెక్నాలజీ యుగంలో. ప్రతి వస్తువు ఈ నానో టెక్నాలజీతోనే రూపొందిస్తున్నారు. మరి శబ్ద తరంగాలను కూడా ఇప్పటికే చాలా వరకు ఈ టెక్నాలజీ సహాయంతో మరిన్ని మెరుగులు చేశారు. ఈ విద్యార్థులు కూడా ఈ శబ్ద తరంగాలను బ్లైండ్ పీపుల్కి ఉపయోగపడేలా చేసిన ప్రయోగాన్ని ఇప్పుడు చూద్దాం.
వాస్తవంగా మానవుని యొక్క వినికిడి శక్తి పౌనపుణ్యం 20 నుంచి 20,000 హెర్ట్జులు. అంతకంటే ఎక్కువ శబ్దాన్ని మనం వినలేము. కానీ ఈ 20 హెర్ట్జులను 40 హెర్ట్జులుగా మార్చి ఓ వినూత్న ప్రయోగం చేశారు ఈ విద్యార్థులు.
Inside the ultrasonic flow meter, pairs of sensors are fitted across from each other in the measuring tube. Each sensor can alternately transmit and receive an ultrasonic signal. Simultaneously, the transit times of these signals are measured. The ultrasonic signals are generated with piezoelectric crystals applying a voltage. Conversely, a piezoelectric crystal creates a voltage when an ultrasonic signal impacts the sensor. By increasing the number of sensor pairs, it's possible to accurately detect and mathematically compensate for flow profile distortions over the entire pipe cross-section. When there is no flow, the signal transit times are the same, upstream and downstream. Once the fluid starts to flow in the measuring tube, the ultrasonic signals are accelerated in the direction of the flow and decelerated against the flow. As a result, the ultrasonic signals now have different transit times, less time in the direction of flow and more time against the flow. Therefore, the differential transit time measured by the sensors is directly proportional to the flow velocity in the pipe. Together with the known tube cross-section, the actual flow volume can then be calculated. The greater the flow velocity, the greater the measured time difference between the two ultrasonic signals. For ultrasonic flow measurement, the sensors do not necessarily have to be fitted into the pipe wall. With a clamp-on system, for example, the sensors are fastened directly onto the outside of the pipe. They can be retrofitted at any time without interrupting the process. With clamp-on sensors, the ultrasonic signal is passed directly through the pipe wall and into the fluid. The signal continues through the fluid, is reflected on the opposite pipe wall, and then measured by the second sensor. In this example, with a 2-traverse installation. The clamp-on design is unique because flow rates can be measured in very large pipes, up to 4 meters in diameter. This possibility increases the areas of application, for example in the water and hydroelectric industries. Flexible mounting, process safety, and cost-effectiveness are the distinctive advantages of ultrasonic flow measurement.
ప్రతిరోజు మనం ఏదో ఒకటి ఫిల్టర్ చేస్తూనే ఉంటాం. ఉదయం కాఫీ మొదలు అవసరాన్ని బట్టి చాలా పదార్థాలను ఫిల్టర్ చేస్తూనే ఉంటాం. కానీ వీరు ఏకంగా శబ్ద తరంగాలను ఫిల్టర్ చేయడానికి పూనుకున్నారు. వీరి ప్రయోగం బ్లైండ్ పీపుల్ కోసం, చెవిటివారి కోసం కాదు కదా. మరి సాధారణ మానవుని వినికిడి శక్తికి మించి ఈ శబ్ద తరంగాలను పెంచడంలో వీరి ఆలోచన ఏంటి? ఈ మార్పు చెందిన శబ్ద తరంగాలు బ్లైండ్ పీపుల్కి ఎలా చేరతాయి?
This is step-by-step procedure of my project. That is, it consists of a 40 kHz oscillator, that is the transmitter section, and then the receiver section, and is a frequency divider and an audio amplifier. The transmitter section transmits 40 kHz signal, and this signal, when it is obstructed by any object, the receiver section receives that signal, and since it is a 40 kHz signal, I have to divide that signal by using a frequency divider. Then I made it to amplify to audio frequency, and then it given to earphones, so that the person can listen to that sound and he can move other side. That makes the blind people to walk properly. And this is my circuit design. This circuit consists of some transistors, resistors, and some one IC. And the most important thing is the ultrasonic proximity transducers. These transducers works on the principle of vibration, that is piezoelectric effect. Whenever the electric signal comes into this ultrasonic transducers, they vibrates and generates 40 kilohertz signals because its operating point is 40 kilohertz. It vibrates at 40 kilohertz. Then it generates, and when the signal gets obstructed by any person or any object, the receiver section receives that obstacle signal and it gives it to the frequency divider section. The frequency divider section divides that 40 kilohertz signal and makes it to the audible range, that is 4 kilohertz signal. And this operation amplifier makes that signal amplified because the signal we have generated is of low range, so it is amplified by this operation amplifier, which works as an audio amplifier here, and that signal is fed to earphones. Then the person can listen to it and he can move to the other side. This is a step-by-step procedure, means our sections. This is the transmitter section and this is the frequency divider section, and that is the division graph. Yeah, this is the ultrasonic transducer section. This is the block diagram of that section, and it consists some essential parts. That is the power cable, acoustic, which deals with the acoustics. That is the generation of signals. And my applications of my project are, it works, the main purpose of designing this project is it works as an electronic guard for the blind. And presently this technology is used by Skoda Lara while it is backing, to prevent the banging with other vehicles when it is bumping, accidental bumping. Right? And it's also used in some non-destructive testing in other applications, and sensors used for liquid level control and sensing clear objects, applications not suitable for photoelectric sensors. Yeah, these are the advantages. Basically, I developed this project by reading some article it was written in some newspaper, that is some recent analysis made that out of 100 people born on the world, there are 30 to 40 people are blind. I tried my level best to make this project as low cost as possible so that every ordinary people can buy this and use they can use for their proper walk, that is the blind people. Particularly for the blind people, I made this, and I took help of my friends, that is my teammates. 4 of us developed this project. They are Dilip Reddy, Manoj Kumar and Santosh Kumar. We worked as a team for about a month and developed this project, and we are further planning to do this project as advanced as possible and as minimized as possible. And now I am going to show my practical work.